The world outside is always changing. How does our visual system keep up? Well, psychologists think that we assume certain constancies, that we have to make an assumption that while the light that comes into our eyes might be changing, the objects that produce those images are not. And here's an example. It's called constancy. So a constancy is perceiving an object as unchanging, even though the image of that object that gets projected onto the back of your eye does change. A door. When I look at a closed door, I see a rectangle. But when that door opens, notice that in 2 dimensions at least, the door is no longer a rectangle, right? It's a rhombus or something else. Now, when someone opens a door, I don't see the door changing shape. I see the door changing its orientation. So my brain has figured out a way to deal with the fact that the retina is flat. It's 2D. And the world is 3D. There are all sorts of constancies. There's constancies for color. So the light indoors and outdoors are different. I can take an apple and say it's a green apple and have it in one set of light and change that apple into lighting in a different place. Take it outside, take it into a place with a red light on it. The apple is still going to appear green. Okay, so once I see an object is having a particular color, I stick with that interpretation. I'm going to show you a video now that shows you how much our interpretation, our perception of the world depends upon context. So you can get a sense of why constancy is so important. Okay, so here's a scanning of the room, and you see a checkerboard that's partially in a shadow and partially in full light. And what's going to happen here is a woman's going to walk in, and she's going to pick up one of the squares in the checkerboard and move it. And that square is going to appear to change colors as she moves it. Did you notice that? It's dark gray in the light and white in the shadow. It's the same piece of paper. Isn't that cool? So the color of the piece of paper depends on the context in which it appears. Wasn't that cool? Okay, here's some more context effects. You see the circles in the top there that are surrounded by a ring of other circles? It looks like the circle on the left is bigger than the circle on the right, the inner 2 circles, but they're not. The 2 circles are exactly the same size. They just look different because of what surrounds them. You see the circles below with the black surround and the white surround? It looks like the circle in the middle, the circle inside the white circle, is a little darker gray than the circle inside the black circle. Do you see that? Yeah, they're actually the same color gray. It's the context that changes them. When an object comes towards my eye, the image that object projects on my eye gets bigger and bigger, right? So the image here is huge. The image there, it's not so big. But I never see the glass change size. That's size constancy. Even though the image on the back of my eye is changing, my perception of the size of the car stays the same. A symbol of depth that we use a lot is 2 parallel lines, and we interpret the convergence of those lines. The lines appear, 2 parallel lines, if you present them, you paint them a long way out, they, in depth, far away from us, they appear to converge. That convergence is called linear perspective, and it's something that we use to maintain size constancy. Okay, this is a very famous illusion called the Mueller-Lyer illusion. The 2 lines there on the top are exactly the same length, but it sure looks like the line on the right is longer than the line on the left. Why is that? Well, psychologists think it's because of the orientation of the arrows at the end of the line. Those little arrows imply corners. And if a corner has the shape of the arrows on the right, then it must be farther away. That's all I'm going to tell you about perceptual organization. So we're done with the lectures for Unit 8. Students in my class, head back to Canvas. Thanks, everybody.